Hello. So we're going to start talking about Git a little bit. Git, if you're not familiar with it, is a way to control version control system. Git is a free and open source distributed version control system designed to handle everything from small to very large projects. It's I don't exactly agree with this. Easy to learn, but it does take there's a bit of a learning curve. And this is the official Git website. So what we're going to do is explore a little bit about Git and what it is and why I made you guys do that GitHub stuff. So the best way that I can describe at GitHub and GitLab and Code Commit for AWS is compare it to like a was it a WordPad? What's the very basic one? Let's see. WordPad. Not a text edit, not text, but WordPad. Okay, so here's WordPad. WordPad. If you're not familiar with WordPad, it's like the default Word document editor. It's not a text editor because it does have some other little things you can do with it. That's not just a plain notepad. Here's Notepad. There's nothing special you can do with Notepad. I mean, your formatting and your editing is pretty simple, okay? With WordPad, you have a little bit more. You could do bold and italicize. And it looks very similar to Microsoft Word. But it's not Microsoft Word. So this is, like I said, the very simplistic version of a document, any kind of document that you want to write, like a Word. I want to say Word document, but that's a brand name. I don't even know what name to say. Just a place where you would write a document, create a document. So you also have, as I'm sure you guys know, Microsoft Word. Okay. So let's think of it like a Word document. Say we want a Word document. I don't like that. Let's undo that. So we need to write a Word document. Okay. Not specific to non-software specific. Okay. We need a Word document. We have a couple of different choices, right? We can do MS Word. We can do Google Docs. We can do there's something called Apache Open Office, which does it's a free alternative suite for Microsoft Office. And then we can also even do the basic WordPad. Basic Word. I keep calling it WordPad. WordPad. Okay, yeah, WordPad's correct. Okay. So whenever, let's see. So we have our choices, right? We can do, we need just to write any kind of Word document. We need something a little bit more sophisticated than a text editor, such as Notepad. But we have our options, right? We have our options for any kind of Word document. So that's kind of what Git and GitHub and all that stuff is. So we have a concept of Git. Okay, we have a vendor or provider interface, whatever you want to call it, of GitHub. We have GitLab, and we have AWS's code commit. And there's more. That's not the only ones, but that's the three that come to my head. But they all have a general purpose, the same goal, same purpose of Git, okay, doing Git functions. Just like this one has the same goal and purpose of doing Word document functions, okay? So that's what the relationship is between GitHub, GitLab, if you're familiar with it, AWS Code Commit, if you're familiar with it, and any other ones that are out there. That's that. So this is the main concept, Git, and GitHub is one of the interfaces, the tools that we use to perform Git. So let's get back over to here. So this is the official Git website, like I said, and we're going to look through here and learn about Git. So Git is basically branching and merging. So the Git feature that really stands out is the branching model. Git allows and encourages you to have multiple local branches that can be entirely independent of each other. The creation, merging, and deletion of those lines of development takes seconds. So if you recall, let me see if if you recall from your assignment which was actually for today, in the learning lab, there were 13 steps for you to take, and 2 of them, or 4, had you merging. So what it was you were working on a separate document to only be merged into the original, the master document. So it's a very similar concept if you worked on any kind of collaborative projects such as OneDrive or Google Docs or Google Spreadsheets, whatever it's called. It's a very similar concept. You guys are all working on, you're going to be in a team environment sometimes on your own, and you're going to be working on creating something, but you're going to have multiple versions just to be able to kind of go back and see where you're at in case something needs to change. Git allows and encourages you to have multiple local branches that can be entirely independent of each other. So the creation, merging, and deletion of those lines of development takes seconds. Let's see. Git is fast. Nearly all operations are performed locally, giving it a huge speed advantage. I'm not going to get into that. Distributed. One of the nicest feature of any distributed SCM Git included is that it, excuse me, it is distributed. This means instead of doing a checkout of the current tip of the source code, you do a clone of the entire repo. You can have a centralized workflow. Every user essentially has a full backup of the main server. Each of these copies can be pushed up to replace the main server in the event of a crash or corruption. In effect, there's no single point of failure with Git unless there's only a single copy of the repo. Because of Git's distributed nature and superb branching system, an almost endless number of workflows can be implemented with relative ease. So let's see. So we have a shared repository, like in the exercise from the Learning Lab. We had a master. It was a shared repo, but every developer can pull their own branch, and they can work on whatever it is that they need to work on in silos without having to worry about what others are doing until it's time to merge them. Let's see. Another common Git workflow involves an integration manager, a single person who commits to the blessed repository. A number of developers then clone from the repo, push to their own independent repositories, and ask the integrator to pull in their changes. This is a type of development model often seen with open source or GitHub repos. I'm not going to get into that. Let's see. Let's see. Okay. So the data model that Git uses ensures the cryptographic integrity of every bit of your project. Every file and commit is checksummed and retrieved by its checksum when checked back out. It's impossible to get anything out of Git other than the exact bits you put in. Let's see. Not going to worry about that. So staging area. Unlike this other systems, Git has something called the staging area or the index. This is an intermediate area where commits can be formatted and reviewed before completing the commit. One thing that sets Git apart from other tools is that it's possible to quickly stage some of your files and commit them without committing all of the other modified files in your working directory. So we have a working directory, and then we are going to use the command of git add. It's going to go to a staging area, and then it's going to go to a commit with a repo. This allows you to stage only portions of a modified file instead of making two logically unrelated modifications to a file. Now you can just stage the change that you need for the current commit and stage the other change for the next commit. Let's see. It's free and open source. Okay, not going to worry about trademark stuff. Let's see. So there's a big community involved with it, which means that there's a lot of things and a lot of resources out there to help you. There is a book you can read online for free. And let's see. Oh, how in depth do I want to go in here? So let's get started about version control. Version control is a system that records changes to a file or set of files over time. They can recall specific versions later. For the examples in this book, you will use software source code as the files being version controlled. If you're a graphic or web designer and want to control every version of an image or layout, a VCS version control system is a wise thing to use. It allows you to kind of go back in case you make some changes that you didn't like anymore. So we have local version control systems. Many people's version control method of choice is to copy files into another directory. It's a common because it's simple, but it's also incredibly error prone. I know I'm guilty of kind of forgetting which folders I have files in. So centralized version control is the next major issue that people encounter, is that they need to collaborate with developers on other systems. So this is whenever you start getting more into a group build. So centralized version control were developed. These systems have a single server and contain all the version files and a number of clients that check out files from the central piece. So then we have distributed version controls. So this distributed version control systems such as Git and some other ones, don't check out the latest snapshot on files. Rather, they fully mirror the repo, including its full history. So if any server dies and these systems were collaborating, any of the client repos can be stacked, copied back up to the server to restore it. Every clone is really a full backup. Let me do something. Okay, I'm going to try to explain this in terms that might be a little bit easier to understand, or you might be more familiar with. So I created a spreadsheet. I'm in my hawking.edu email or account, and I created a Google Doc spreadsheet. And okay, so what I'm going to do is I can share it. I can copy the link. I want to change that to edit, copy the link, and then I am going to send that link to another email that I have. It's also Google. Okay, but it's outside of Hawking College. So I'm going to say that this person can edit it and hit send. Got it. So whenever you have whenever you create a repository in GitHub or anything, you can make it private or public. So just be aware of that. And so I'm going to go to my email. Okay, so I have it here, open up in my other email, my other account. Maybe. Did it put me in my first account? Yes, it did. Hold up. Okay, so I'm in my other account. So, and when I make any kind of edits, you guys probably already seen this several times working with other stuff, but I can make any kind of edits and it's going to show in the original. So the difference where we start getting different between here and Git is that any kind of edits I make right here, it will not automatically show in the original. For that, you need to do a pull request. But once a pull request is done and it's merged and all that stuff is done, then it's going to show in the original. So it's a way of collaboration, just like you use Google Sheets and Google Docs for any kind of collaborative effort. It's a way of collaboration. Let's see. Where was I at on this? Next. We're not going to get in the history of it. Looks like it was born in 2005. So again, Git is nothing more. It's basically just a form of version control. There are 3 states in Git where you can modify. Pay attention now. There says here's the main thing to remember about Git. The files can be modified, staged, and committed. Modified means that you have changed the file but not committed it to your database. Stage means that you have marked a modified file in its current version to go into your next commit snapshot. Committed means that the data is safely stored in your local database. So what we're going to be doing is, let's see. So just like how WordPad was basic for a Word document, like the very basic, it's already included in your computer, nothing to download, nothing to get from the internet, none of that stuff. What you can do for Git is using the command line. command line interface. Okay. So this is, like I said, it's the default in your computer, right? To create a Word document. For Git, this is the default in your computer. This is available online, this is available online, this is available online. Okay. So let's get started. So where am I at? What about this? No, I'm not doing that one. So we're going to install for Windows. So there's a few ways to install for Windows. The most official build is available for download on the Git website. Just go to that website. Download will start automatically. Note that there's a project called Git for Windows, which is separate from Git itself. For more information. We're not doing the chocolatey one. Another easy way to get Git installed is by installing GitHub Desktop installer, which is part of GitHub. The installer includes a command line version of Git as well as a GUI, graphical user interface. And it also works well with PowerShell and sets up a solid credential caching and saying, with like CRLF settings. We'll learn more about those a little later, but suffice it to say that there are things you want, and you can download that from a GitHub Desktop website. Let's see. So some people may find it instead useful to install Git from a source because you'll get the most recent version. The binary installers tend to be a bit behind those. Git has matured in recent years. If you want to install Git from source, you need to have the following libraries that Git depends on. We're not going to do that. Let's go on. Let's see. Let's go back to here. Let's go ahead and download for Windows. Open. Yes. Next. Let's go ahead and put icons on the desktop. Next. Yes, we want VS Code as the default editor. We're going to use the one that's recommended. We're going to leave that default. Leave that default. Let's just leave that default. Leave that default. Leave that default. I'm going to pause this while that's okay. When that's done, we don't need to read the release notes. Click launch Git Bash. Okay. So you should see something that's similar to your name where you see mine. I'm on my office computer, but I got Pinwell. I log in information right there. I'm in my office, so this is my office computer, so I'm assuming that's related to that. I think this is for the fact that it's a 64-bit and we're in the master. Okay. let's see. There's something else here. Hold on. Documentation. Okay. So let's watch a few of these videos.
Hi, I'm Matthew McCullough with GitHub, and I'd like to take the opportunity today for those of you who are new to version control to describe at an abstract level what it does and how it relates to your job as a knowledge worker. I want to begin by describing at a very high level the standard tasks and steps that a knowledge worker might go through in creating some content. This could be a designer, person who works with documents, or, as is most frequently the case in the realm that Git is talked about, a developer or someone who writes code. All of those roles have the common behavior in place that we create things, author new files, write the content, we save them. We then subsequently make some edits or changes to those files, corrections, additions, requested modifications, and then we save them again. This seems like a simple set of steps, but how would you graphically represent that? That saving the thing again and again is the goal and where version control helps, providing you clarity as to when you did it, why you did it, and what the contents of the change were. Open for review at any time in the future. If we drew a picture of the activities of you working on one of those files that we just described, you might, for each of the points in time, describe what you did to the file, why you changed it, and then you'd like the tool itself to record what the contents of that change were. From one word to another, a spelling correction, the change of a color or a background, or adding a company logo to the top of a web page or even a Word document. For a single individual, this doesn't seem too hard, and for a single file, it seems relatively straightforward. Many individual products are putting this into the product themselves, this idea of keeping a history. What would this look like in terms of a graphical client that sits atop of Git? Here's GitHub for Mac, at which point I can look at any entry that I've done in the past. I can see the before and after of the change, and I can go into the details of that with the description in context and make sense of why did I make this modification. For a single individual, I repeat, this is again rather straightforward and rather simple. But where Git really shines is when we start talking about this in a collaborative sense. You and other team members trying to do the same thing. Even worse, on the same files. When you do that, you need something much more capable than a simple revision history of a single file for a single person. You need the idea of keeping track of who changed it, when they changed it, why they changed it, but the capability of the tool to unify these back together in what is typically referred to as a merge. These actions, these interleavings of you and the team members working on the same, similar, or adjacent files is handled adeptly by a full-fledged version control system like that of Git. This idea of bringing these changes together is shown here in the same graphical user interface. Tim making modifications, in some cases literally at the same time that I'm making them, but the tool handling it with precision and relative ease. Simply show who changed what when, and if there needs to be a unification of the two, bring up a concept that we call merge and help me bring the two sets of changes, mine and Tim's, back into a unified and resolved good and final state. Let's recap what Git brings to the table and why it's a good implementation of a version control system. It's very lightweight. It's one of the newest implementations out there, even though it's had a full 7 years to mature, and it's extremely fast, which is important to users because the tool just gets out of the way. It provides you that history, which we said some individual tools, document editing and so on, might provide on an individual basis, but Git can give you the history of all of the files that compose a project: graphics, designs, documents, and in many cases, even some form of programming code. Next, Git facilitates this not for just one person making modifications to changes, but actually bringing them together, facilitating collaboration, people simultaneously changing the same or adjacent files and bringing them together for a unified effect, making sense of this "we're all working at the same time" kind of idea. Lastly, Git is approachable for any type of knowledge worker. This is not focused just on programmers, but equally serves designers and document authors. The graphical user interfaces provide a very pleasant experience with this version control system, a visual way of reviewing the history, and a simple double click and right click for navigation and changes through those versioned elements. I hope you give Git a try, and appreciate that you've given me a few minutes to talk about what this might bring to your job as a knowledge worker.
Okay, so that explained a little bit better on what Git is, or what's version control. So now what is Git?
Welcome to another screencast on Git. This is Matthew McCullough with GitHub, and I'd like to talk to you today about Git enabling your projects and how that goes above and beyond what we've discussed about the basics of version control in the first episode. When we're looking at Git, the big idea here is that we actually have an implementation of the idea that we were previously calling version control. Git is one specific flavor of this. There are many options out there today, but it's a very popular one and very successful one. And I'll give you a couple of reasons why, revealed in 3 parts. First and foremost, many version control systems require a complicated server setup to be effective. On the other hand, Git is actually locally enabled, meaning that you can version control items just on your desktop, just with a single piece of software available at the command line. You don't need any complicated server software, but if you want to use a server component to collaborate with your colleagues, that'll be available in a few minutes. Let's revisit a diagram that we've already examined before, and that's one of history. This idea that we brought up in our version control podcast described the idea of having many people contribute to a project. If we look at that from the perspective of just a single computer, a single person sitting at the desk at any given point in time, this is relatively simple. You could even take turns at the keyboard, and the implementation in Git at the command line for someone that we'll call developer Dana would look something like this. It would start off with the initialization of a project, the setting up of the Git control structures. That's done at the command prompt with a simple git init and then the name of the project. That creates a directory, a folder that can contain the project files as well as the control files that store the historical elements, the history snapshots of your documents, images, source code if you're working with a program. Git add is the command that actually notices the files and puts them into a kind of holding zone, ready to permanently be committed. And then nicely aligning with the word that we just used, commit is the keyword that actually permanently records a historical version or snapshot of the files as they exist at a given point in time. That's a simple use of Git, but we want to take it to the next step when people are actually collaborating in a fashion when they're not at the same machine, when they're not working at the same time. And it actually gets quite a bit more complicated from the conceptual side, but hardly any more complicated from the implementation side of Git. Git is designed from the ground up for team collaboration. Every feature that you see is centered around making this experience simple, easy, being effective for even hundreds of developers. Having this at the core of our tool takes us back to that picture one more time. People working in sequential fashion. However, they really don't work in sequential fashion. It's this more complicated diagram. It's people working at almost different times, but with overlaps, and all wanting to bring back their work to the home base to have it incorporated in the primary copy of the project. While that's a wonderfully simple way to describe it, it doesn't really model reality. Reality is that people are working at different times, but with slight overlaps, each taking a personal copy of the files as they see them at a point in time, performing their own enhancements to them, but then bringing them back to the central copy and wanting to unify, the technical term is merge, those changes with the primary copy of the documents, the images, and the source code. It's this overlapping of time and almost parallel work that complicates a lot of matters. The implementation is significantly helped by Git. With an example that uses both Doug and Dana working on the same project at effectively parallel times, Doug can work on his master branch, an arm of the project, adding some new graphical work such as a logo, and then sending that to a central server, now adding that network component to the idea of version control. And then having Dana also participate, perhaps again at exactly the same time as the work that Doug is doing, with her contributing her feature work, perhaps some programming code, and then bringing that into the central server-based copy as well. But that last step is the critical one, bringing all the code into a unified set, merging together both Doug and Dana's work. That can be done with Git as simple as retrieving the copy of the centralized versioned files down to Doug's individual machine, and then executing a command that merges all of that work together. It'll provide help if there's any conflicting files. It'll walk you through the steps of deciding whether you want to keep Dana's or Doug's changes if they happen to collide. And in the case that they're working on similar but different files, it will merge them together completely automatically. The third category of person to speak about when discussing an implementation of Git is the person who will use it for a long time, find all the deep crevices and features of it, and in fact want to stretch it to its absolute maximum. That person is also served well by Git. Even though it's very easy for the introductory person, it's also very capable for the advanced individual. You can find that through its Unix-like structure, the ability to glue together these small programs and use option switches to control the behavior, that it suits the needs of an advanced version control user extremely well. Piece by piece adding of little segments of a document, and the committing of just some of those pieces that were selected, and then a historical graphical representation that can be done even from the command line, showing when people branched files, when they merged them back together, who did what when, on which date. All of these option switches, which at the moment for a beginner might seem intimidating, are actually extremely satisfying to the advanced user. Git serves both ends of the spectrum extremely well. Version control is a simple concept, but it's complicated by the work modes of today. People working in parallel, sometimes on the same files. Git serves that beginning user extremely well. It serves the merge capabilities well when more than one individual's work needs to be brought together. And it scales well to the advanced user over time, wanting to have precise control over the commit and over the visualizations through a series of small commands and through a rich set of option switches. Thanks for listening to the concepts behind version control and now specifically applied to Git. I hope you'll join us for our next episode.
Okay, so that I'm going to stop this video right here. That's kind of like the basic concepts of Git. It's just like anything else. The only way you're going to have a better understanding of it is to do it. Before I turn off this video, I want you to see, I think it's this one. Yeah. So here are some of the commands that you can do in Git. It's a cheat sheet. I'll go ahead and print that off for tomorrow. So that's all on this video. So I know it's a lot and it's probably kind of a little boring, but it'll get better. I promise. Trying to figure out which one. Let's just do it this way.